mine, I think it's about 3.4 grams per ton. When you talk about the 6E. When you talk about the 6E. Then the concentrator upgrades it to about 120 grams per ton. And that 120 grams per ton now is the one that now comes into the plant now. So for a PGM concentrate, it has got to be bought. That's why we have got the that's manufactured in South Africa by a company called Zimplats. Then the next stage where the process goes to is actually the smelter itself, the furnace itself. You see this whole structure here. You have to go close, okay? But you see there's some blackish structures inside that whole structure. That is the furnace itself. We have already put the furnace structural steel. We have already put the furnace walls. We are just going to put a roof on top of it and start putting the refractory bricks. We already have the refractory bricks, specialized bricking which is made in Australia, in Austria, by a company called RHI, because of the sort of temperatures that are operating in there. Because we are talking about 1,600 degrees for the mat. You almost heating the material to a liquid. And when you even get to a liquid, you also heat it a couple of hundreds of degrees above even the liquid as temperature. So it makes it very aggressive. So you find the furnace it's got bricks around it like a pot. And it has got to be compressed under pressure, the bricks around it, to ensure that, because this is so aggressive that even if it's and then we put the associated equipment inside the furnace there. On this side of the furnace, that's where we take out the mat, which is the valuable product. On that side there, that's where we take out the slag. That main structure you see the greyish one here is the slag cooling tower. It's just meant to ensure that as we granulate the slag, we take the heat off the water that we utilize to granulate the slag. And you are circulating those volumes of water in there. Otherwise, if it's not cooled, then the granulation tends to become explosive, because you are putting in a liquid asphalted material. Then on this side, I come back again to the mat. There is the converting process, which was the CEO saying it was left on that slide. You are now taking your green mat from the furnace. It goes into the converter. Yes. And in the converter, you take out also the unwanted material. And it's still called the converter slag. Yeah. It's still called the converter slag. But mostly you are removing iron and sulfur. Iron and sulfur out of there. Because iron content, when you now talk about the refinery, iron and silica, I think, very sensitive to iron and silica, particularly as the product goes down to the base metal refinery. So because of that, then you then take out the mat, and you also have got a separate granulation process there. So all this yellow stuff that you are seeing, Minister, these are new installations here, all the way from there. This particular furnace here, in comparison to the one that we had before, that is running there, it's about 3 times the size of the one that is existing. The one that is existing is around 13 megawatts. This new box we put in here is about 38 megawatts. And there's only 3 of this size in South Africa. I think it's mostly Anglo.
Yeah, mostly Anglo. And
the
even Implats.
Yeah, the Implats. So Implats has got 230 megawatt furnaces, and some of the large Anglo operations like Mortman, they also have got the 30 megawatt furnaces. The technology is supplied by a very recognized and reputable company called H, particularly to do with PGM furnaces. They are the ones who dominate that market because of the aggressive nature of the process that I've just described in terms of making sure that the liquid metal is contained. In fact, when BHP started off operations here, this is one of the key technical challenges that they experienced, was the furnace failed to operate. It had frequent run-outs. It didn't have certain facets that are required for a PGM furnace. They'd almost like designed it for a base metal refining furnace. It didn't have binding systems, it didn't cooling circuits in there. So that's why we selected the Edge Africa especially with the leading OEM. They then came in and fixed that furnace in 1998 to make it operational. That's how good they are. Yeah. Even some of a few furnaces made by other OEMs, they had to come in and also fix those in 1998.
When it was still BHP.
Yeah. Okay. So they tried to operate, they couldn't operate the furnace because of frequent runouts. And they brought in this, initially designed by a company called Aircam, but the technology obviously didn't work for the PGM. Then this side here, this is where now, because we are basically smelting sulfide containing ore bearing the ore here. It implies that the sulfur now comes out, the sulfide now comes out as sulfur dioxide gas. So there is the handling system. What we are now seeing here is the handling system. We have got space that we have here in that location there. There is technology that then takes that gas and conditions it for it to be able to go into a wet sulfuric acid plant, which is the technology that we're going to be using to actually abate that acid. So that wet gas cleaning plant there will condition it already procured. This is what the CEO was indicating. We procured it from Germany and it's already delivered. Then it will come to this area here, the seaboard there which are buried in the ground. That's where now the wet sulfuric acid plant is going to be situated. It will convert that sulfur dioxide gas into sulfuric acid, and it will be concentrated sulfuric acid. I think we're talking 98% concentrated sulfuric acid, mostly utilized in fertilizers and other applications. Then that stack you see there, it's meant to ensure that if the wet sulfuric acid plant is not running, we also take the yes. Then part of the weak material, SO2 material, which cannot be treated by current technologies, then just goes through there because it's weak.
The concentration is
small. That's the purpose why you see all this large concentration.
I just need to show him the BMR side to say.
Yeah. Okay.
No, that's fine. The BMR that side is covered. Okay.
Yeah.
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 Yeah.